Hello, in the first part we went through the demonstration and introduction to the trade studies, automatic trade studies in SysML. And there are quite a lot of material available actually. We can find the sample there, there is, here we have, in docs.magic.com you can search for the trade study analysis, you will find description how to do it, and the sample is available. Let me show that samples under the simulation here. Trade study example, this one. It shows a couple of variants, but kind of have more information than maybe it's easy to understand. And what we want to do now is to create this model from scratch and to do it as a tutorial. So for that I will open just initial project, which has just few packages and pretty much not much else. It has block diagram with the basic satellite model here, and here we have this one, right? So the satellite, the solar panels, optics, battery, and then 3 alternatives of the panels, solar panels. And then what we can do, first of all, let's import requirements. So here we have requirements table, and let's take requirements from Excel. We'll use one of the methods here. We have here, you see 2 columns with requirements. Just copy, go here, paste, because the columns number is the same and the order is the same, so we get requirements like optic cost, satellite cost, and satellite mass limits. Okay. What else now? Now we could associate those requirements with the satellite, right? But we can drag them here. Very convenient to do that in diagram, right? We visually see. Here's our optics, here's our satellite. But then we don't have those roll-up patterns like for cost and mass, and that's what we will do here first. We'll apply those roll-up patterns to get the total cost and total mass parameters on the satellite, and that will enable us to do those trade studies, because we'll have variability on solar panels with different cost and mass, optics, and battery. And this is just a minimum case of scenario. You can have much more complicated models in real life, but this is just to show the process and how that works. So okay, then now we'll apply pattern, tools, apply roll-up pattern, and will be cost, and then another one, tools, apply roll-up pattern, will be mass roll-up pattern, create values. As you see, I'm using this one. If you want more about roll-up patterns, there's separate video, please check that. And here we see in those cases is all good, we get that, total mass and total cost to satellite. But in this case, there is some limitation because generalization. So we want to input those initial values to those 3 variants. For that, we need to open this one. And again, this is more totally about roll-up patterns, not about, trade studies, but, like when you open specification, you can go here, value properties, and redefine cost, total cost, mass, and total mass. We are redefining them to set in this context, like for example attached, so it will be like maybe the default value, for example, for the cost will be least, like 10, and mass will be the biggest one, let's say 30, whatever, then 3 axis properties, again do the same, cost, let's say 20, and mass, let's say 20. I don't talk about units because that is not like really what you need to kind of learn to do. You can do it by yourself, using separate steps, and then cost here for the 2-axis. Let's say, actually for this one let's do 2020, and for this one 3-axis let's do cost, the most expensive 30 and the mass least expensive like 10, right? So we have those variants on this part, and the total goes here. So now we could satisfy our requirements. So we can take total cost is here, cost limit, right? And total mass is here. We can change those two right here. And then optics cost, total cost, right? It's here. And then we can formalize those requirements, by creating constraints. So we can just extract constraints automatically using natural language analysis patterns. For that, we will enable those patterns going to 2 options, project, and then general, and then here use requirements term glossary, yes. And now we'll see that actually we have this underlined, and it recognized the total cost should be less than 100. And same for everything, based on language, based on which property satisfies what. Okay, so that was it. And one more thing, if you will run this model simulation run, you see that I don't get, results. The reason for that is that zeros are not created as empty values. I need to click on that. And that's another property which you most cases want to set, and in version 19 this is environment option. In version 2021 it is project option. So the options for simulation are moved. So you go to simulation and then go to here and then initialize empty values to 0 is true. This option needs to be set again in environments for 19 version and earlier, and for 2021 in project options. For all that time you use rollup patterns. This is actually like almost like by default should be set to true. And then options, environment option is, you see like environment options for simulation are not available 2021 because they moved to the project options, and originally they were here, and for 19 you will find that same option here on the environment option. Okay, so we have this one. Now next step will be to actually go to the trade study analysis and create the diagram, and create the context for satellite for trade study analysis, and inherit that context from trade study analysis pattern. So let's go here to trade study analysis. Let's build block diagram, and let's take our satellite system model, trade satellite here. Let's zoom in a little bit. Okay, now let's take this custom block, trade study analysis. So this is our analysis. Let's name it satellite trade study analysis, and our system is part of that, right? That's like common case, And then let's create a block and start typing trade study, and you see you get trade study pattern here. This pattern comes from the SysML Sim Toolkit, lib package. Here used in the read-only, you can right-click here, select in containment tree, yes, and find that here you see customization of SysML. So for SysML, so it's actually not from Sim Toolkit, but from SysML custom profile. And then I will switch auxiliary resources off. I don't need to see them here. Okay, so that's where it comes from, and then I'm inheriting from it in order to get those properties here for this trade study analysis. Okay, so then next step will be to create internal block diagram and set up all that, analysis alternatives, objective function, utility curve, and other things, assignment binding to those score property and so on. So, okay, create. we inherit from the satellite. What we need batteries, we need total cost, total mass, and we need optics, and we need solar panels, and that's it. Okay, so now let's make this screenshot larger here, and now let's do next steps. So the score is actually what we'll need to generate. Winner gets automatically generated, N gets automatically, out of spec gets automatically generated as the configurations which does not satisfy one or another requirement based on those requirements we have. So battery, optics, and solar panels will need to assign two alternatives. Total cost and total mass gets as the inputs to the objective function. So this objective function we need to create here, and this is our objective function. So we can take constraint here and even name this, specify the type for the constraint. You see I specify the semicolon and then objective function, and it gets created as a constraint block here. And here I can type, you know, like for example, score equal minus 0.4 multiply, and that would be what cost, less important cost, plus 0.6 multiply mass. As you can see, I use minus because it automatically generates score as the biggest the winner, so the mass and cost are both like as least as better, you know, so that's why I'm using minus in front. Now I'm using the automatic parsing of parameters based on variables and showing those parameters here. And then score goes down here, binding connector, and mass goes here, and then the cost comes here, and then we have this setup here. So now and now what's next? We have this objective function. We are skipping utility curve, which would take, you know, cost and mass and would normalize, you know. So I will run this model without that, and that's a good idea because we could check that it works, you know, and then set the utility curve, and then it is actually not something which will break, you know, initial test of the results. And then here, optics, battery, and solar panels, I need alternatives. So this is a big deal. We need to take the reference here. For example, for optics, I create a reference property, take the optics, drop it here, and then associate with binding connector, and then apply alternative stereotype. Actually, let's do that for all of them. Reference property, and take the battery here, associate with binding connector, and then let's take a reference here. Let's do the solar panels here, and then associate with binding connector. Then take all of them and apply stereotype. Will be alternative stereotype apply. Doesn't show stereotype by default, you know, but you can go to symbol properties and, for example, show stereotype text and icon, and then also, you know, for example, tagged values, show tagged values on shape in compartment, for example, close. So we have 3 of those alternatives here. And then, for example, for optics, let's say for solar panels, I will go to this reference, go to tags, and we'll say that kind will be subtypes, you see. So that makes sense because solar panels are actually subtypes, right? So it will take one of those variants and will run through all of them. Then for the battery, I want that it would take it from the Excel, right? So here I will go here, go to tags, kind, create, and it will take from Excel. And for the source, I need to specify instance table, which would be synchronized with this Excel. So not like a value is imported from Excel, but just like in connection to Excel. So for that, let's go to alternative package. For the battery, I have this already here, so let's just delete them, you know. I will create an instance table, in the battery package, let's create a new diagram, instance table, and here alternate setup that battery will be synchronized here. You see the battery. Then I need to hide those total cost and just leave the properties which you want to get from Excel, cost and mass. Okay, and name. And then let's take this Excel here, batteries. You see, like, it has cost, mass, and name. So the first column, don't save it. First column will be cost, and then mass, and I can embed it to the project. I will just drag it, you see, to the battery package. Actually, drag it and wait a little bit with the right mouse button. Come on. Battery, wait. And then create attached file. So wait like 3 seconds and then release and then choose that option. Okay, so now we have this setup, but the Excel was not used to synchronize, right? So we need to establish the synchronization. So you can drag, you see, from here on the table, and that will establish the synchronization with this file. Or you can also go here to options, sync option, and check that you're actually selecting this file from file. And then you can also map those properties here. You see, like, read and map those properties here in any kind of depth in that Excel file, from starting from any place, you know, and you know, 1 to 1, you know, in this case, like, but you can change the mapping, you see, like, if you need to, you know, and you have more complex mapping. No issue with that. Okay, and don't click on import data, because we want to have these batteries actually read from Excel. Now for the optics, I want to actually have the instance. So again, I will create instances of the variance. So create a table, instance table here, and then it will be associated with the optics. And here what we'll do, again, we'll hide total cost, total mass. I will change the order. I think the mass, that cost, in my case of Excel, and those are instances, and let's say that I will get them, you know, from this Excel, you know, as a previously copy paste. So mass, cost, just copy the values, copy and paste here. And this one I could call it just like optic 0, right? Optics 0 here. So I have those variants here with different optics, and we have variants with different batteries. We are in Excel here, you see here, and we have different variants with the different solar panels, and all of that gets as inputs. So in order that it would be automatically evaluated, I need to pick them here. So let's go to optics, let's go to tags, kind, create table, and this will be table, instance table, right? And source, create value, and then go to tree, alternatives, and this is optics, and then I need to switch here to any element to choose actually instance table. You see, by default it shows type and package, so it does not give that option. And then we'll pick the battery. So we see instance table is here, and then we'll pick the battery again, tags, Excel, source, create, that will be alternative, alternatives, batteries, instance table. That's it. Okay, so we have those alternatives here, and we have subtypes, and we are coming here. Automatically will be selected variance, and then will be compared. The score will be identified, and the score, if it is highest, will be saved as a winner. So we should be able to run this. Actually, we can assign also, you know, some stereotypes here as, oh, doesn't matter really this one. Now to run this model, actually we need to set up simulation config and go to simulation config, create diagram, simulation config diagram, call it satellite trait study, and then take that not satellite but trait study block, and then results block, results package, use it as a results location. The reason for that, if you want to get outputs as instances, because if results package is selected, so instances will be generated as a result each time. And you can also choose, for example, let's take a look. Record time step, then it will be even time of that instance generation, you know, recorded, and then you can run silent, you know, automatically from command line those simconfig, you know. Also, you can export as in CSV export config. You can create here. Check the documentation or tutorials, you know, for that. That's it, you know. Now we should be able to run, and let's test this model and see that it actually generates what we expected. And actually, before going to generate, go to results and create instance table here, and then set that satellite trait study analysis will be here used as a result. And even you can check that you would see as a columns those optics, battery, and solar panels. Okay, so let's run this analysis. Yes. So all the variants are evaluated. And results are produced, and the scope was not set for the table, so that's why we don't see that here. So result is here. So we have optics, we have a number of variants dropped, we have timestamp, like 50% of the variants were, you know, incorrect based on some requirements. We have the solar panel selected, battery type selected, and optics selected. And if we'll go to those requirements here, and we'll change, for example, like just remove this requirement, right? For example, because it's limiting the optic size. You see, like optics now is limited to the less than $4 million, right? If we'll remove, then other optics will be available. So those are optics, you know, like cost, like you see, like optics 1 and optics 0, you know. So let's run this trait study again. Let's see the results here. Okay, so 0 failed, configurations 90, and score 47, and even higher score 47, and that's the optics which were selected. Okay, so now the last step actually which we wanted to show here is that you can add those normalization value, normalization utility curves. And one type of the utility curve, as you can see here, we have this one, right? It takes the best case scenario and worst case scenario and current value, and then produces the result. So instead of passing the score directly here, we need best case, worst case, and then the score will be produced. Okay, so again, the same method to create it. So we can create a constraint here, type like utility curve, right, for example, and then paste it here. This is one way to do it, you know, because we are using IBD, we don't have this equation wizard here, but yeah, in any case. So then here we have like ability to parse and then ability to show them. And let's move those guys out of here. You know, we don't even need to see them. They are not needed. And then now we'll have this normalized, plus we need twice to use this one. So that good thing is that once that constraint is created, we can reuse it twice. So this is UC, and then drag it here, another one, right? So we can just show that. Here you see, like, so this we can call it, for example, like a mass. This will be cost, right? And then, so then mass MOE will go to this place, right? And the value will be input here, right? So we can just move this one here and this one here. And then the same for this one. MOE will go to this place. And then the value will be moved to this one, right? So let's move that one here. And that will go here, right? So all good for now. But there's best and worst, right? Cases. So those best and worst cases we need to create manually, because this is based on our input data, right? So let's go to our trade study setup here. Let's do the layout. So we have the satellite trade study, and here we have just ability to create the value properties. So value property, best mass, and we are using just a real as a unit. And maybe let's go to the containment tree, take this best mass, copy, and then best cost, and then copy them again, and then worst mass and worst cost. Okay, done. Now let's do the values. So for the mass, what would be the best mass scenario, right? So the least mass scenario, right? So we can take the here the mass of the 10, right? That's the least, and then the mass of the optic will be 1, so 11, and then the mass of the battery will be also 10, so no, mass of the battery will be 10, so 21. So that's the best mass, equal 21, right? What would be the best cost? So again, 10 from here, best cost is 10, then 1 and 21. Again, the same situation, because we used kind of, you know, simple values. Equal 21, right? What will be the worst mass and worst cost? So the highest, right? So it will be 30, then will be, you know, like 6, so 36, and then for that would be 36, and then 50, so will be 86. Same for that, for both. Okay, and that will be equal 86, and here the same 86. You see why we are doing this? Because the values are quite different, and if we are not normalizing them, you know, using this utility curve, so we get, you know, different results, and it's not like really the weight is equal. It makes them equal, right? The weighted purpose is to weigh the criteria impact, not like to you know, normalize them. Normalization comes here. Now they will be normalized from 0 to 10, you know, from 0 to 10. Very good normalization method. Now let's run the same analysis and see that it works on oh, actually we need to assign those values, right? So let's go to show display. Actually just show all the values. So here's as you can see here, best case and the cost here, best case, best cost, worst cost, bind, and then here we have this also, best case and then worst case. Okay, so now let's run this model, and this is all set up now. Let's run this model again and see result. So nothing should change really, just like a result score, you know, and yeah. Actually it should change because now it's normalized, so this is different different weight comes now from both, you know, because now they are normalized and the result could be completely different. Okay, so here we have this out of spec, and you see normalized score is -4, and yeah, different result. So that's, as you can see here, made sense to do the normalization curve. And let's use this also here to take this cost and satisfy. And now let's run again just to see that it works actually. So now should be different situation. For example, half of those out of spec should be not should be half, 50% of out of spec, and result could be also different. Yes, so as we can see here, and still result is the same actually based on that normalized, at least what we see here, right? We have this optics, the battery, optics, and then here we have solar panels. So thank you for your time today, and that ends this tutorial. So the sample will be available in the description of the video.